I recently came across a bunch of these hydrometers. Specifically, these ones measure specific gravity for light liquids, as you can see here on the scale. So let's go ahead and test this one. And this should float to about 1. So you put it in and rotate it so it kind of doesn't touch the center exactly. The specific gravity of this is 1. There you go. How cool is that? You can see the specific gravity of olive oil, which is about 0.91. And you can see that this should not be touching the bottom. If this does touch the bottom, or if there's any holes or cavities within this oil, both of those things can affect the measurement. Cavities in the hole will affect the purity of the density of the purity of the density measurement, and the thing, if it touches the bottom, then it's clearly not floating and therefore will not give you a complete specific gravity unless it is touching the ground exactly at the point where if I took this amount, exactly this amount away, and it was touching the ground, it still would technically be an accurate measurement. But would it be the best type of measurement and or a safe measurement? Probably not. But if oil is about 0.91% of the density of water, then why does oil remain on the top whenever I pour it into water? Shouldn't 90% of it sink below the water? Well, this is the case, but only for solids, not for complex things like liquids. And this is not exactly just this simple case of surface tension. If I seal the oil up to basically make it a solid, then about 90% of it should actually go under the water, as it does.